welcome back to my channel. Today's class we are solving a quadratic function, a quadratic equation, and we are asked to look for the value of p if this equation has equal roots. If it has equal roots. Now I haven't said this. If it has equal roots, it means the function here is quadratic must look. Let me now give you a background check on what they call this equation. We have what they call this equation as being quadratic. We have ax squared plus bx plus c is equal to 0 is a quadratic equation. In this case, when I compare the two of them, I'm going to get some values actually. But for now, let me just show you something before we solve this question. We are asked to solve for the value of p if this equation has what equal roots. The roots of this equation here, they are the x we have here, the x, that's the roots. But before we do that, this one we have here will give what we call the formula that we call almighty formula local balance. We have x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This formula is called the quadratic formula that can be used to solve any equation that can only be factorized. I haven't said this. For us to have equal roots, this one under this rule is considered. Now we have three areas of what? Roots. We have the real roots, we have the equal roots, and we have the complex roots. But for this question, we are asked to look at the value of p if the roots are equal. If the roots are equal, it means the roots have equal what values. Let's see how it goes. Listen. Now for real roots, if you have if the roots are real, you want to have that b squared is always greater than what? 4ac. If the roots are real, as in s equals to 2, s equals to 3, or just two different values. Now if the roots are equal, for equal roots, as the equation above, for equal, we're going to have b squared is always equal to what? 4ac. But if the roots are complex, for complex roots, we're going to have b squared is always what? Less than what? 4ac. These are the conditions under what? Quadratic what? Roots. But for this question here, we are asked to look for the value of p, the unknown here, if the roots are equal. So we're going to use this middle one to solve the question. So for equal roots, we want to solve, we want to use b squared is equal to 4ac. So let's continue. Now above, we're going to compare these two, this quadratic function and this one. So we can say that here, there's one here, imaginary one. The value of a here is what? 1. A is equal to 1 in the above equation, comma, b is, this is b, is s coefficient is b here. In this case, what? 2p, b is equals to what? 2p, you see, and we have c is equals to what? The constant here is now what? 3p plus 4. That's the value of c. So let's now use this formula to look for the value of p, the unknown. So we're going to throw them here now. So b is what? 2p. We're going to throw it here. So we're going to have 2p all squared is now equal to what? Formula 4. What is a? A is what? 1 multiplied by 1. What is now c? C is what? 3p plus 4 multiply in bracket 3p plus 4. What in that step? We apply algebraic function here by simple expansions. So we're going to have, this is not giving what? 4p squared is now equal to, we're going to have 4p squared here now, equals to what? 4 bracket 3p plus 4 as usual normal. So when we expand this, we're going to have 4p squared is equal to, we're going to have what now? We're going to have here 12p then plus 16. Understand? So we're going to now make it look like another quadratic function for the value of p. Wow. So we're going to have what now? 4p squared minus 12p minus 16 is equal to 0 is now a new quadratic function for the value of p. It means that we're going to have two values for the value of p. So let's go ahead. So for me, I like to make my thing so easy. I'm trying to break it down. So I'm going to divide 2 by 4 here. If I divide 2 by 4, I'll be having 4p squared over 4 minus 12p over 4, because 4 can divide everything here equal to 0. So now I have what now? P squared minus 3p minus 4 equal to 0 equal to 0. So from here, I'm now going to factorize. I'm going to factorize this function. So I'm going to multiply these two first. So I'm going to have minus 4p squared. What are the two factors? That if I multiply it, I'll get this. And if I add it, I'm going to get this. I'm going to have the factors will be p minus 4p. This time, this side 1 and 4, 1 minus 4, give me this, then so give me this. So let's go ahead now. So let's come up here. So the next step here now is I'm having 4p squared, which give me two factors, minus 4p squared. Give me what? P minus 4p. So I'm going to throw it into the main function now, which is p squared. We have minus 3p minus 4 equal to 0. So we're going to throw it here now. P squared plus p minus. So let's see how it goes from here. We have p squared now. P squared. Alright, so we have p into bracket what? P into bracket p plus 1. The minus 4 is common here. Minus 4 into bracket p plus 1 is now equal to 0. So we're going to do a bigger factorization here. We're going to factorize this one. So now have p plus 1 into factor, remaining p minus 4 equal to 0. So it means that p plus 1 is equal to 0, or p minus 4 is equal to 0. So finally, my value of p for equal roots is minus 1, or p is equal to what? 4. That's the value of p for equal roots. So I'm looking at the fact that the original value for p should be what? 4, for us to have equal roots. So I would like to check it and put the value of 4 here to see if the roots are actually equal, but not to this class. So in our next class, we're going to see another form of questions. Just stay tuned and remember blessed. Thank you. God bless you all.